Hello and welcome to some statistics revision.
That's lovely.
We're all very excited.
We love statistics.
Yay.
I'm Connor Durkin.
Are you?
Are you?
I'm Will Carne and welcome to S2 or Statistics 2. This video has got all you need to know for an A star and has the whole of S2. Yeah, it sounds fun, doesn't it?
But as with all our videos, if you have any questions, you're more than welcome to ask in the comments section below.
You are incredibly welcome.
More than welcome.
Shall we kick off?
Is there a more than welcome? It's just welcome, isn't it? You're just very welcome. There's no more than welcome.
A quick definition for the maths rookies among you. Exclamation marks start to mean something at A level, as they mean factorial, or all the integers up to that number multiplied together.
Now, binomial expansion, I assume you already know a lot about from C2 and possibly C4, but to recap, it is a way of expanding two terms in a bracket to a certain degree, n.
Generally, the term is given by this.
Oh, look at that.
N over R, or, oh, for God's sake, NCR, which is your coefficient, and then P to the power of R multiplied by Q to the power of N minus R, where Q is just 1 minus P. Carry on.
Me carry on?
Yeah, where N choose R is the coefficient, and where R is the number term from 0 upwards that you're on.
And N is the degree of the bracket.
Which we've said many times.
There are plenty of ways to find the coefficient, but they're all in our C2 videos, so we'll move on.
Now in S2, X squiggle BI doesn't mean that X likes a bit of both. It means that X is binomially distributed, where N is the number of events and P is the probability of success. Therefore, the probability of x being one value, shown by little x, is given by this p to the power of x multiplied by 1 minus p to the power of n minus x, all multiplied by the coefficient.
Ooh.
See, isn't that good?
It's very good.
But you may want to work out the probability that x is any value below a limit or above a limit.
Limitation. You can do that by either adding up all the terms included in the inequality, or if it is less than or equal to, you can use the tables given.
Yeah, look at these tables. Whoa. But these only give the probability that it is less than or equal to the value. To find more than or equal to, just find less than and sort of take it off 1. Just be careful to...
of the equal to things, yeah. Now, some other facts are the mean, or E of x, which is given by NP, and the variance, which is given by NPQ, where Q is 1 minus P.
As we said earlier.
Yeah,
but it's that simple. That you do need to know that, but that's it. That's your mean and your variance. Isn't that lovely?
Isn't that lovely?
Now, you will probably have to model a problem using binomial expansion. There must be a fixed number of trials. The trials must be independent. There can only be 2 outcomes, success or failure. And finally, the probability of success must be constant.
But don't get us wrong. There is another expansion to bother about, and that's the Poisson distribution.
Ah, there's something fishy going on around here. Okay.
If you don't know what that means, then look, your French teacher.
So here, why is Poisson it's distributed
in a Poisson way with respect to lambda, which is a little Greek thing again.
If you can say that, I don't know if you can say that. Well, lambda is the mean and the variance, really, making finding
and variance of x very, very easy.
Yes, it is.
It's easier than trying to say it.
The probability of y being a value little y is given by the equation e to the power of minus lambda multiplied by lambda to the power of y all over y factorial.
It's y yelling at someone.
Then, if you have an inequality, you can do it manually. Which may be quick and nice just by using what I've just said and adding them up from 0 to where you want or whatever.
Or you can use that weird load of tables, which is not very nice.
No, there's only one. Look,
there's only one table for that.
Yeah,
Poisson. I forgot about that.
It's very easy.
Dogs.
Right.
But again, be careful, as it only gives you equal to or less than.
If you want to model something using the Poisson distribution, then you are assuming 4 things.
That the events occur at random, these events must be independent, the average range of occurrences remains constant, and there is a 0 probability of simultaneous occurrences.
Now, if n is very big and p is very small, then you can approximate the binomial distribution with a Poisson distribution. This is because q will be nearly 1, so E of x will be nearly the variance. The mean will nearly be the variance. Therefore, you can use np as lambda in your approximation.
A few little things to remember. The standard deviation, or little sigma, is the square root of the variance. And with the Poisson distribution, you can use recurrence relation to get terms or know some general examples. But this is all you really need to know if you're feeling just that little bit lazy.
Yeah, so you can just know a few examples about like the first term and the second term. You couldn't have general.
I've just looked at the PowerPoint and I just saw y squiggle pomp. Moving on.
Continuous random variables. These histograms are known as frequency density diagrams. So the total area of the bars is always 1.
Yes, it is. Taking smaller and smaller intervals, the graph will approximate a smooth curve, which in this case represents a continuous random variable. It takes an infinite number of possible values, and you can find probabilities from the area under the curve.
A continuous function like this is known as the probability density function, PDF or f of x.
Not PDF, that's a document type.
For it to be a PDF, it must be greater than or equal to 0, and the total area under the line must be 1.
You can find the probability between 2 points, A and B, by integrating between these points.
A cumulative distribution function, CDF, or big F of x, is the cumulative probability of the situation.
It can therefore be found by integrating the PDF between negative infinity and what we call x naught. This is just a particular value for x, but it's important that you use it.
Subbing in a value for x naught will give you the cumulative probability up to that point.
Instead of negative infinity, you can just pick a number that you know has no probability, like in this case 0.
And then you can integrate it normally. To get the PDF back, just differentiate the CDF. It's rather simple, really.
You can find the mode by the highest point on the PDF graph, the maximum point or turning point, or something along those lines.
Yeah, just it's the highest point on
something
your
along
graph.
those blurred
really.
lines. The median can be found by making the CDF equal 0.5 and solving to find x naught. You can find quartiles and percentiles the same way, but that's GCSE stuff, really, so we won't bore you.
Yes.
We'll come on to the mean in a minute. Now, notation is very important. And for us, the hardest thing is drawing the brackets.
For me, yeah, I cannot draw these brackets. Can you draw those?
I-
Those squiggly brackets?
They're just, I have no
cannot
artistic
draw
ability.
them. I cannot draw them. All right. Now, you can have multiple mini functions describing different parts of your main function. As a nature determining the probability changes, really. These will be defined like this. With your PDF, anything not defined by a function will be 0. I have no probability, so we just say otherwise, or O/W.
The CDF will then be found by integrating the mini functions, keeping the same inequalities. Except now there is 0 and 1, as at the end of your CDF the probability will be 1 as it is cumulative. Very important that.
So yeah, you just go from having 0, 0, 1 to 0 and 1 because it will be 0 before your graph and 1 after your graph because it's cumulative. Yeah? Yeah?
Yeah.
Good. Right, move on.
To sampling.
No, we're doing the mean. You forgot the mean. E of x or mu can be found by integrating the PDF multiplied by x. Again, positive and negative infinity can be...
two values you know are typical of positive and negative infinity. It's very typical values to use.
So if you have multiple mini functions, then just use two integrals with different limits.
The variance, VARX, or sigma squared, is x squared multiplied by the PDF, integrated, minus the mean.
Yeah.
Yeah, okay.
Is that the thing? So it's, you can see, it looks a lot simpler than Connor just made it sound. And, this is probably the hardest part of the topic, all of this, as with lots of mini functions and get very complicated
That
doing
makes no
finding
sense.
variance.
A picture is 1,000 words, so if you look at a picture, it's 1,000 words. I only said like 10 words there, so that picture is, actually, no, that works out. As
It's not a
1,000 words.
picture.
It's a picture of a little thing.
It's not a picture. Do you know what it is, Connor? Do you know what it is? It's words.
It's not words. That
It
is not
words.
words.
They are words.
That is not words.
They are
That
words.
is algebra and letters.
Arguing with me.
I
Let's
will argue to my dying breath.
Sampling now as we go to this rather tropical looking place to study these frogs.
Froggies! Or in French, I've forgotten, les grenouilles or something. A census will examine the full population, whereas a sample will only look at some of the population. The sampling frame is a list of all the units or elements of the population to be sampled. Random sampling is where each member of the population has an equal chance of being picked, and simple random sampling is where selected units are not replaced. All of this
Yes.
I'm taking is relatively common sense, but if you struggle or have any issues, feel free to ask in the comments, as I'm sure you will.
Yes, and these, you may be asked a definition for one of these, which is always good. Well, it isn't actually. Now, there are a number of possible sources of bias. Non-response, where simply people don't reply, making your sample biased to the type of person who did reply.
Lazy people who didn't reply, rather.
Subjective choice, where the person taking a sample seeks the people out for, like, on a street, going up to them, which again may lead to bias.
You either go ask a lovely lady about something than a really old homeless man.
Opportunity sample, where the people, whoever's available at the time, take part.
Self-selection, where again certain types of people who volunteer may affect the validity of the sample.
And finally, an incomplete sampling frame, because it will exclude certain units or groups.
Now, a statistic is defined as a function that depends only on the observed value in a sample. The probability distribution is known as a sampling distribution of that statistic.
Yes, and that's pretty much it, really.
Sampling.
That's it. You may be asked to identify what's a statistic and what isn't, but that's
Just stick with the definition.
that's
You'll be
a
fine.
bit, really. Right, on to
Uniform, continuous, distributions.
This is the easiest bit. All rectangular distributions. Go for it, Connor.
Onto uniform. It takes the same value over the range in which it is defined. It has no mode and it is symmetric about its mid-range value. Therefore, the mean and median will both be equal to the mid-range of the distribution.
So it's everything we said earlier for continuous distributions, except it's just a straight line.
Yes.
If
Blurred
continuous random variable x has a uniform distribution over the interval alpha beta, then its probability density function is given by
That lovely little.
yes,
that,
there.
with the
Yes,
horrible
1
brackets.
over b minus alpha.
It's
That's
got
it.
Indiana Jones font. I like it.
Yes, it has. Do you like it?
I do like it. It's very adventurous.
Now, as we said, the mean would equal the median, which is just alpha plus beta over 2, which is just the mean. You should know that, really. The variance
is given by beta minus alpha squared divided by 12. I said that quite quickly. You should
Yes.
read it.
The cumulative distribution function is then given by obviously
another
it's
one.
0 when x is less than alpha, less than or equal to alpha, and it's 1 when it's more than or equal to beta. But when it's between the two, it's x minus alpha over beta minus alpha. Now you can work that out. Yeah, you can. Yeah, wait. That's pretty much it. Yeah, that is it. It follows all of the continuous distribution formats. It's just a special case, as we said.
Special.
You can prove it all if you wish, but it's not necessary. But you might want to have a rough
It's not
idea
required
how
of
to prove
you.
it.
Moving on
Okay.
to continuous distribution approximation.
So you may want
it's-
to approximate
yeah.
discrete uniform distributions like this with continuous distributions like this.
To do this, you need to do continuity correction.
Continuity correction.
Continuity correction, that's the one.
Yes.
I'm very good for these things. It's like in films where they've got continuity errors. So as discrete distributions take whole integer values, you find a value plus minus 0.5 around your value x.
Yeah, so you're just taking your discrete and you're filling it out to make it look continuous. Does that make sense to you?
It makes sense to me.
Yeah, this is just because, as you just saw with the graph, you're kind of filling in the gaps.
Oh, you said your kind as in my kind. It's you are kind. Anywho, on to approximations. Firstly, binomial or binomial. as
Did you
probably
just
know
say
it.
binomial?
Binomial? Yes.
If n is large and p is close to 0.5, then np and nq are greater than 5, sort of as a rule of thumb. Then you should be able to approximate the distribution as a continuous distribution, where mu is np and variance
More
is
Greek letters.
npq.
Everyone loves Greek letters. To approximate the Poisson distribution, and lambda should be large, ideally more than 10 as a guide. You approximate particularly when a probability interval is required.
Yes. Now, one thing to note is that you should never approximate twice. So don't go approximating binomial as Poisson and then going from Poisson to normal. Don't do that.
Then the rest is all last year's stats. But as a quick reminder, here's how to get your value of x into a value for z, which you will need to do so you can use the tables. Remember?
Yes.
They will have
There
lovely
it is.
tables.
Z equals x minus mu over
Oh, look at that.
standard deviation.
Oh, look at that.
There we
Love those tables.
However,
Moving on
did you
to...
say however?
I did. Well, however.
Okay. Hypothesis testing, which is our last topic of today.
I love testing hypotheses. And finally,
Yeah.
we will move on.
Which, in more complicated terms, is where you test stuff.
Why is that copyrighted?
Because it's
is that a
test
brand?
stuff.
Is that a brand?
I've
Have you
just
made a
made it,
brand?
yes,
Test stuff
called
brand.
Test stuff.
Oh, we've met millions of those.
So
You come up with two hypotheses, one null and one alternative. The null hypothesis, or HO, states that there is
H0.
states that there is no relationship between your two variables. If it is binomial, you will have p equaling something. If it is Poisson, then you will have lambda equaling something.
Then you pick your alternative hypothesis, or H1. It can be one-tailed
Hi.
or two-tailed. One-tailed if you state which direction the significance will be, so P will be more than or less than. Really?
Or two-tailed if you don't know, and it could be either.
Yeah. So, yeah.
Bit of
Now,
confusion.
state the significance level that you are using to test your null hypothesis. Apply it to the result of your test, and your conclusion should be either
There is sufficient evidence, or there is not sufficient evidence.
in which you either accept the alternative hypothesis or accept the null hypothesis.
Then state your conclusion in reference to the given problem.
In a hypothesis test, the extreme part of the sampling distribution is called the critical region, and the significance level will give the size of this critical region.
If the observed value lies in the critical region, then you reject the null hypothesis.
A common significance level is 5%, but you may use another one if you so wish.
The smaller the significance level, the less likely you are to reject H0 incorrectly. And also, the more likely you are to be unable to reject HO when it is untrue.
Yes. A larger significance, though, therefore means the opposite of that.
Reverse what we just said. To increase the effectiveness of the test without changing the significance level, you can just increase the sample size.
Now here's a nice example for you. The significance level is 5%, and the null hypothesis is that lambda is 10.5. We're doing Poisson, if you were wondering.
Therefore, the alternative one-tailed The alternative one-tailed hypothesis is that lambda is less than 7.5.
Yes. Any values with a probability less than 0.05 or 5% will be in the critical region.
You can find the region on your table. As you can see in this example, the critical region is when x is between 0 and 2. The critical value being 2, the first x value in the region.
Yes. If it were more than 7.5, then that's a bit more tricky because any values with a probability higher than 0.95 will be significant. In this case, it's when x is 12 or more.
Now, if it is two-tailed, then the significance level is split and the critical region is on either end. So if we chance the significance level to 10%, then the answer we've got is correct.
Yeah, because then it will be 5% either side, which is the answer we've already got from our last question.
Da-da-da-da.
So to recap, the critical value is the first value for which the null hypothesis will be rejected. And that's it. If you have any questions, then you can ask in the comments, especially if you're confused about anything. Which
I ask in the comments? I'm confused.
Or you can find us on Facebook at facebook.com/WAHEY Productions.
Or that Twitter thing that we never use.
Yeah, at WAHEY Tweets.
I believe so.
Contact me. I'm at Will Carne.
You're not having mine.
I've actually got at Will Carne.
Do
I
you?
got it. I've got happy.
I think mine's not that. Mine's not my name.
What's yours?
I'm not telling you.
It's on screen now.
Oh
dear. Happy revising. Good luck in your exams. WAHEY Productions do make other videos. Other revision videos, so go check them out if you're not manically revising, which you're probably not. I've been Will Carne.
And I've been Connor Durkin still.
And this has been a video by WAHEY Productive. Thank you very much for watching. Goodbye.